Tom. Good morning, everybody. Thank you so much for taking the time. This is a genuinely exciting time for us. I was telling this today morning to a couple of people. This feels like I'm the parent of a newborn baby, and I'm taking the baby out for the first time to the public. So the excitement and the butterflies are both in.
You might want to back up. Your remote has the same problem I do.
Presentation done. Get fast already.
Just stop and start over from right where you ended before that thing went crazy.
All right. So exciting day. Want to share what's going on here. My background has been mostly in enterprise Wi-Fi. I spent 14 odd years at Aruba Networks from 2002 to 2016. So a lot of what you guys have written, I have read, internalized in those roles. And after 2016, I joined a company called Federated, which was doing something in CBRS. And my first realization in the first few months there is I thought I was entering another wireless company. I thought I ended up entering another world. I realized that enterprise Wi-Fi and cellular might both be wireless, but they barely can speak the same language. And it was very fascinating for me, and that go went on. I actually met Mehmet as a part of that, where he was one of representatives from Qualcomm in the founding of the CBRS Alliance. And we started brainstorming about what is this possibilities and all of that. One thing led to another. Over the last year or so, what became obvious to us was that there was an incredible opportunity to have cellular networks actually be used by enterprises. And we started hearing a lot more use cases, applications that needed it. And we looked around and we just genuinely felt that this needed to take a slightly different approach in how that platform needs to be built. That was our belief, and that's what we went out to do with Celona. So Celona's primary mission is to essentially remove the friction to have enterprises adapt and adopt cellular networks. Day one, we expect it will be LTE in the CBRS band that we'll talk a lot more about today. In the near future, it'll be 5G in whatever spectrum bands open up and what is available. That's going to be the future. So with that concept, really the thinking we had was we wanted literally to have an opportunity to get these two worlds together. That is kind of the concept that we wanted today. We are early on in this company's journey, but we felt like it is time to start at least speaking this common language. So that's the reason we got excited about having this opportunity. And with that, I'm going to basically hand it over to Mehmet. And the way we're going to do it is the first section is predominantly going to be Mehmet sharing his insights about what is CBRS, what does LTE in CBRS look like, and what does it mean to enterprises. That's really the focus of the first session. And we would love perspectives from you guys who have heard it, not heard, but for the first time, whatever it might be. We are genuinely interested in that perspective. So with that, let me hand it over to Mehmet and take it away.
Thank you. I think I'll just use this. Hi, everyone. Good morning. I'm Mehmet Yavuz. I'm the CTO and co-founder at Celona, and really excited to be here with this opportunity. I am coming from that other world that Rajeev has mentioned. I've been on that world on the cellular side for about 20 years. Out of those 20 years, I worked on 2G, 3G, 4G, and lately 5G. 15 years of that was at Qualcomm. I was at corporate R&D. And for about 10 years, I was leading the small cells project at Qualcomm. So it's been a long passion for me to bring the cellular technology to the enterprise use cases. I have been on that journey, and along the way, we met with Rajeev and decided to go on this path. And then I realized the heart of the enterprise activity is really here in Silicon Valley. So I made the move about a little more than a year ago and came here. And really excited about all these things. I want to share with you some background on LTE and then CBRS, Citizens Broadband Radio Service, how it all comes together. As Rajeev said, any feedback, input, we would really appreciate. And I did not have the opportunity to participate in the past for these events, but I heard so highly opinions about you. So please feel free to provide your comments and questions during the slides that I'm going to go through. So having said that, I will just keep doing this. First, let's talk about LTE. LTE is essentially the 4G technology, which was standardized in 2008. The first standard was Release 8, and it brought concepts such as all IP network, including voice services, and it brought OFDMA. And this technology has been around for about 10 years, little more than 10 years. Since then, there has been different releases. Now I think we are at release 15. So over the years, lots of enhancements, lots of field testing to make all of these things work. And what are the key points of LTE, if I want to summarize you, is mainly OFDMA and bringing together with OFDMA all the other benefits that's required for a truly mobile service. And in a nutshell, what OFDMA is basically you have a frequency channel like 20 megahertz that you operate in, and all the cells, I will use the term small cells or base stations, meaning essentially APs, they all operate on the same channel. And typically they operate on a clean channel as a network, and each base station or AP transmits data and control channels simultaneously, what we call as universal frequency reuse. And as they do that, they have multiple frequency tones, right? Out of the 20 megahertz, some of the tones are for control channels, some of the tones are for data for different users. And it goes on continuously, and every 1 millisecond, the allocation of the tones can change, but you're simultaneously serving many users at the same time, not only with one base station, but with multiple base stations. And what this allows you is, for capacity purposes, first of all, you're continuously using all the available spectrum simultaneously, constantly getting channel feedback, and the scheduler decides how many tones to assign to each user, what kind of modulation scheme to use. So constantly filling all the capacity available as a network. So it's not only the peak rates, but it's also the network capacity gains. And secondly, and very importantly, the control channels and signaling channels have specific tones that are preserved, and all the devices get control information and signaling information through that, and you have high reliability and continuous operation. So when you go into mobility, for example, all the mobility signaling happens very fast, very reliably, and the base stations or access points are in constant communication. So you can now push the mobility to like 300 plus kilometers per second, seamless mobility, and so forth. So as I said, this has been in the domain of more like a macro cellular deployments for a long time. And the passion, especially for me, was to bring it to other use cases, such as enterprise. And one issue has always been the spectrum. Because typically you have licensed spectrum for the mobile network operators that they pay a lot of money, and enterprise don't have that. Now, recently, that has changed. And this what we'll talk about today. That is the CBRS spectrum. So if you go there, basically, what happened is around 2015, FCC looked at the spectrum from 3.55 to 3.7. There's 150 megahertz of spectrum. And in this spectrum, there are some incumbent users, such as the Navy for shipborne radar. There are some fixed satellite stations, and then there are some wireless ISP providers. Now, the key point is, for these incumbent users, they use the spectrum in very few locations. And when they use the spectrum, they use only a small chunk of the spectrum, a small bit of the spectrum. There are lots of analysis that showed that majority of the locations in US, the spectrum is not used. And whenever it is used, it's only a small portion. So the FCC approached this as a really groundbreaking approach compared to other regulators and said, OK, let's bring a new mechanism to use this spectrum for commercial users. And the first thing, of course, is you need to protect the incumbents. Whoever has deployed some infrastructure, they need to be protected. So they are the tier 1 incumbents. But then FCC established these 2 other tiers, the tier 2, priority access licenses. And that is enabling some licensing of the spectrum up to 70 megahertz of the spectrum can be available for licensing. And that 70 megahertz can be anywhere within this 100 megahertz. And the licensing of it will be more at a county basis. And when somebody applies for a license, they can only get up to, one entity can get only up to 40 megahertz. So that's the second tier. Of course, second tier needs to protect the first tier. And the third tier, which is a very exciting opportunity, is the Generalized Authorized Access, GAA. And in this tier, in a particular location, like an enterprise, if nobody is using the spectrum, that entity can use the whole 150 megahertz. If some incumbents or PAL licenses are using some parts of the spectrum, the remaining part can be used by the GAA layer. And all of this is very well coordinated through a centralized coordination. And essentially what happens is, if you have an entity as a facility or an enterprise, within your domain, you can get exclusive rights to a certain part of the spectrum. So I have said a lot of things. I just want to take a pause. If you have any questions, comments, please.
So GAA versus what we're used to dealing with in the Wi-Fi world, unlicensed, right? So where in unlicensed, we all have to essentially play together. GAA has this tiering, is what I'm understanding?
And centralized coordination.
And centralized coordination.
Yeah,
okay.
It's a very, very key concept, and I'll get into that. A centralized entity, as we call SAS, Spectrum Allocation Service, allocates the spectrum for GAA users depending on their location and depending on the radios that they use. And I'll describe that a little bit later.
So assuming you're in the GAA bucket,
Yeah.
no federal paperwork, no licensing fees,
No, nothing. You just
respect the rules and go.
Actually, it's all done by the access point or the base station, right? Once you deploy a small cell, for example, on the ceiling, it connects to the internet, gets the permission from the centralized spectrum coordinator, and it will all happen in the background within minutes. Now you're operational.
But this tiered access is...
Excuse me, I think the gentleman's question was whether GAA requires certification, and it does. All 3 tiers require certification by the FCC.
Oh, the equipment needs to be.
But the end user does not have.
I think the end user was the question.
Excuse me.
Yeah. Good point, though. Yeah, it's really, the equipment needs to have Part 96 certification, but the end user just uses the equipment. And,
Uses it.
Exactly.
But so the difference is in our world, we're unlicensed. We have to deal with everybody, right? Microwave ovens and blah. In this tiered framework, we only have to deal with incumbents.
And if there's a PAL licensee in that region.
And if there's a PAL license,
Yeah,
okay, yeah.
exactly.
So
You got it.
nothing else though runs in these frequencies. Nothing generally generates noise. Nothing.
I mean, not to my knowledge, really.
That's fantastic.
Absolutely. I mean, that's the really exciting part.
Yeah.
So now you can have this technology called LTE 4G and in the near term 5G and use it in the span.
So if I set up and my radio registers, does that mean the next person who's in my region gets shunted off? Do I instantly become an incumbent?
You get coordinated is the right word that I will use. That centralized spectrum allocation server decides on the allocation of the spectrum between you if you are in very close proximity to each other, right? The nice thing with the 3.5 gigahertz band is it's in the really right spot. it doesn't propagate so far on the outside that you will see a lot of interference from buildings to buildings to buildings. But inside the building, it's perfect spectrum. It's somewhere between 2.4 and 5 Wi-Fi bands. It provides great service in enterprises or in the local areas.
Sure, but if we're in a co-located building and Keith moves in next door to me and we're both GAA, we're going to fight. If I decide I want priority, I go file for a priority access license.
You have
I win, right?
You have the second tier has priority over the third tier.
You gotta go spend money.
But there's enough channels.
Yeah, that's the exact point.
Yeah. You have two.
There's 150 megahertz of spectrum, and that's a significant amount of spectrum for a technology like LTE, really.
Realistically, what size spectrum chunk do we need? Like a 20 megahertz channel or something? 10?
I mean, it can be 20, 40, depending on what kind of data rates you need. I mean, you can push it to maybe 80 megahertz for some applications.
But
the
for
technology is
standard,
capable.
like voice over the network.
I mean, typical LTE will be 20 megahertz chunks, but some operators can carrier aggregate that to 2 or 3 or 4.
We're just now getting used to subdividing that 20 megahertz primary channel down into 10, 5, 2, and whatever. Is there a default channel width?
Yeah. So so the ecosystem came together and said, okay, let's put together some rules for using that 150 megahertz. And that was the WIN Forum, Wireless Innovation Forum, and the CBRS Alliance, and they channelized the 150 megahertz into 10 megahertz chunks. So the fundamental unit is the 10 megahertz channels of 15 of them.
Okay.
Please.
So on that scenario where both Keith and Sam are going this route and it's being coordinated through the connection back to the internet, let's say they get hit by their area gets hit by some kind of weather event and they lose the back end connectivity into the FCC and all of that for a week. What happens in the absence of that connection?
Yeah, that's a very good point. And there is a constant connectivity you need to maintain with the spectrum allocation server. So if you're thinking of some applications where you cannot get that minimum connectivity to the cloud for extended period of time, the service may not be available, as you can imagine, right? You don't want, because the whole purpose of this is to create exclusive, clean spectrum, and you cannot compromise from that.
What defines constant connectivity? If I
I mean, there's a timer. I believe it's around like 10 minutes heartbeat rate.
Yeah,
Am I right?
I
Is
think
it
you
100?
need a ping every 10 minutes at least to get it
Yeah.
done.
Okay.
And you get a license granted for about 4 hours every time you do that. So, but that doesn't change. And then that just stays. And then you basically just keep.
By the way, I'm looking at Rajeev because this was his product at Federated Wireless. So he's deeply involved into the SaaS.
Maintains the spectrum allocation server.
FCC, yeah.
Is this an FCC thing that they will
Yeah,
always
FCC
Yeah.
approves.
something that-
Exactly.
FCC certifies a set of people to be SaaS admins.
Okay.
Exactly.
Like
And then-
a third-party company could.
That's exactly right.
Exactly.
That's
And there are multiple companies like Google or Federated Wireless who provide that service today.
On the back end to make sure.
They are.
That's right.
They are. And they are certified by FCC for operation in this band.
Thank you.
All right, that's,
All right.
yeah.
Okay, so we talked about the spectrum aspect. One key point is FCC didn't mandate any technology for this band, but what happened is really in the ecosystem, when the ecosystem players came together, quickly the decision was to use LTE for this band for multiple reasons, because of all the benefits it brings, and then this band is used in other regions in the world. So there are some devices in terms of hardware supporting this band. And so this essentially the de facto technology right now is LTE and eventually 5G for this band. We talked about the coordination of the spectrum. We call this lightly licensed model. And we talked about the channelization. And maybe one point to highlight is that it's not only the peak rates here, but the network capacity, as I said. And also there are 2 categories of radios that can be deployed. Category A can go up to 1 watt, 30 dBm. Category B can go to 50 watts, to 47 dBm. So that can even enable some rural applications and so forth where you want really long-range coverage. All right.
And you can do that all just on GAA
Exactly.
If you happen to be in an area where that's open.
Yeah.
Exactly. And it's all coordinated through the SAS. And I'm not going to spend maybe too much time on this, but this is just explaining how the whole process that we discussed works. So when an AP or a base station is installed, it gets the backhaul connectivity. It provides its location and category. Is it like what is the transmit power category to the SAS on the cloud? And then what happens next is it requests for the available channels in that region. The SAS looks at the database, looks at all the other base stations in the vicinity. There are some detailed terrain models, propagation models. Based on all of that, the SAS comes back with a range of available channels. And then in response to that, the base station asks particular channels to operate. The SAS approves those channels, and the operation starts. So at step 3, the base station is already active. No involvement, no paperwork, none of that.
So we're used to dealing with, I have, 10 APs and RM's going to put them all on different channels, right? Is this the collective infrastructure phones home and says, I need 10 channels, and the infrastructure is allocated 10 channels that are then subdivided by some controller, or is it like an individual?
So, perfect question. Really very important point. And both are possible. But what will happen typically in an enterprise is there's this entity called domain proxy. So you may have 10 APs. They're connected through a domain proxy. And as each of these APs asks for the channel availability from the SAS, you'll get a set of channels. Then within the enterprise, you have the option of how do you distribute these, and then you report those specific channels for the specific APs to the SAS.
One way to look at it, coming from my Aruba background, this is how I think of this problem statement. You know how in the Wi-Fi world, each of these algorithms has to go detect DFS on its own. Out of that forms a list of available channels, then goes and listens and says what's the quality of each of these channels, and then does the channel selection and so on. The equivalent here is go to the SAS. SAS has done the DFS part already and told you the available channels, is giving you now the reading of each of the channel qualities. Now you can pick your own best channel. And once you have that algorithm done, the implementation of it can be done at a per eNode B or access point level or at a system-wide level. That's up to the smarts of the implementation.
Okay.
Exactly.
And location is determined, every radio's got GPS, or we program a set of coordinates into a controller somewhere?
Exactly. Both options.
Both the options.
Both
are
options
possible.
are possible.
Yeah, and one of the
Exactly.
things, just relevant, I think, from a practical reality world is some of the characteristics like location, because they are so critical to the operation, FCC has required that the installer has to have a certificate. And that's a certification that you can do through an online course. It's about 3 to 4 hour course. You get a certificate, a digital certificate, and that needs to be installed. So there's a workflow that we can show you when we're doing the demo. We'll show you more about it. But it's, I think it's some of the lessons learned over the years about these type of things and what has not worked. So it's actually been very well thought through.
How precise does that location GPS data have to be? Because if you're like installing this at campus-wide.
So it is plus minus 50 meters, kind of XY, that long is what's required.
And
Go ahead.
you said class 1, class 2.
Class A and class
A
B.
and B.
Yeah.
Different
Transmit power.
different GPS or different
I don't.
requirements?
I believe they are the same requirements.
Even though they're massive cells.
I don't think that
There's
that long is.
subtleties around it where category A, which is indoor, unless it is at an elevation, you have slightly less stringent requirements. Because if you're not at an elevation at lower power, then your ability to interfere is lower. Whereas category B, because it's so high power, the highest level of stringency. But it's minor nuance, to be honest with you.
And so when you're feeding back to the SAS, what channel you're on, do you also then say I'm also operating at this power level, which means my implied coverage area is
Exactly.
this?
You
Yes.
request for a power level. You can then choose
Choose
to
the
operate anything under that power
That.
level.
But the category A versus category B defines how much maximum power you can
Request.
transmit, right? Request. This is the 1 watt versus the 50 watt.
So the SAS isn't just channel allocation, it's also power.
That is right.
Essentially, that's correct.
Yes. So you
That's a good
might
point.
get a channel available at a lower power level.
Exactly.
Okay.
You had mentioned that the elevation has an impact on the allowed power that you get. How does it know the elevation?
It is one
So-
of the characteristics that is provided to the SAS in this API.
But the
Exactly.
GPS is generally not very accurate
Correct.
as far as elevation
Yeah.
goes. So is that something that I'm on the honor system to enter?
So the requirement is if you are above 6 meters of the average terrain height, there's that additional requirement that comes in terms of being very specific about some of those details that you mentioned. So there's that.
So it's on the
Note
fourth
in
floor
there.
of a building, fifth
Correct.
floor, it'd be, you
You would
start
have
to
to
have
provide
additional
that.
Exactly.
requirements.
So I think FCC has set the, what is required. It is up to the implementation to say how do you do it and how do you remove the friction of getting that deployed.
And since so much of this equipment is going to be presumably deployed indoors, what are the provisions for getting a GPS signal to these devices?
So that's part of the certification, right? The technician who's getting certified it needs to meet that plus minus 50 meters lat long requirement.
Right, but if it's inside and it doesn't get a GPS signal, what do you do? How do you get the device to get a lock so that it can provide its location
Oh, for the
approval?
So if the device is not using GPS to lock for time sync purposes, I mean, the location can be manually entered in terms of for that particular AP by the installer who's installing that AP.
Okay,
But there needs to be that accuracy requirement met.
okay.
Yeah.
Is that the physical installer, or is it the guy that's slapping it up on the roof, or is that the guy who's actually bringing it online?
Correct. It could be.
It could be both.
Okay.
Exactly.
And so for installation certification, I realize that's probably beyond, Celona scope, but is that an individual entitlement or is it an organization entitlement?
Individual.
Or-
Individual.
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 Yeah. That certification that Rajeev mentioned, that online certification is on individual basis.
Okay, gotcha.
Back on the
So-
GPS coordinate, if you have a poor GPS coverage inside the building due to lead glass or something like that, if you have a poor GPS coverage inside the building because of lead glass, can you turn on? So if you have a poor GPS signal, then you have to put an external GPS on the top of the roof. So that can
That's
happen.
the,
Yeah.
Yeah.
So that's, and you can have a GPS drop from that to the rest of the building. Exactly. Just moving ahead, I want to talk about some of the deployment models in terms of how this technology and band will be consumed. One on the left side that you see is the mobile operator using this band. And essentially from mobile network operators' perspective, this is more channel, more band. They will utilize it. Verizon had public announcements indicating their plans to use this band. But this is essentially an augmentation of their existing license spectrum. So they will have their license spectrum, and this can be used to aggregate on top of the license spectrum. So that's what we call as mobile operator capacity augmentation. The second model that we are very excited about is a new model. This is where essentially, as we discussed, it's an enterprise managed and controlled deployment for all the devices and use cases that a particular enterprise has. The term that's also used for this is private LTE. You may hear that term as well. That's what we mean by the second model. Now, once an enterprise deploys this network as a cellular enterprise network, it also opens the possibility of serving the operator devices, right, such as smartphones and so forth. So when somebody walks in to an enterprise which has an enterprise cellular network with their operator-provided phones, then they can get service potentially from this network. And it can serve to multiple operators as well. That's what is being called as the neutral host radio access model. So that's like a third model. And in terms of timing, if you will maybe go to the next one. So everyone is very excited now in the CBRS community because the band is becoming available in September. There's a launch event in DC on September 18. Chairman O'Reilly and lots of legislative and other representatives will be there. There will be an announcement of the initial commercial deployment, ICD, and that will be in the third tier, right, the GAA layer, as we discussed. And then after a few months, later this year or early next year, the expectation is have full commercial service across US. And then what we also show here is the enterprise 5G standard, as we mentioned in 2020, maybe in the second half. That will be putting the requirements of the 5G new radio for using this band. And the CBRS Alliance is very much focused on that one now.
So that's going to be called something other than 5G standard for enterprise or 5G?
Yeah, I mean, the term we use is, a little bit loose. So the specifics here is the technology is just like LTE, right? Let's take a step back. When we talk about LTE for CBRS, the physical layer, the layer 2, layer 3, all other aspects of the technology does not change. Okay. What is added is these additional things that we discuss about the spectrum coordination and all that as an upper layer, if you will. Okay. So similar things need to be put in the 5G, and the channelization and so forth needs to be ironed out. So those are a few things on top of the existing 5G and our 3GPP standard.
So we're not going to see a 5GE or a new 5G standard come out?
No, this is not a 3GPP standard. This is really CBRS Alliance specifying the operation of the 5G new radio in this band.
Got it.
And so that will trigger the 5G evolution more in the 2021 time frame. That's what we expect to see. And meanwhile, the PAL licensing rules are decided in terms of, it will be at the county level. As I said, it's 70 megahertz of total spectrum allocated. One entity cannot get more than 4D. The auction date is not very clear. And it's likely to happen somewhere in second half of 20 or maybe in even 21. But the good news is all of these deployments are starting with the GAA at the third layer. And maybe just to bring it all together, I think we highlighted all these points. So when you take a step back and look at this, it's really enabling a new lane, a new spectrum for enterprises to use. And when the LTE-like technology and eventually 5G comes to this band, it can enable new business cases, new use cases, new applications for enterprises. So that's the very exciting part for us. And I will just take a pause here to see if there are any remaining questions. Otherwise, we can take a break. Please.
Oh, go ahead.
I was going to say, do you see that being like an overlay solution to our Wi-Fi infrastructure, or are you seeing it more as something you would add to an access point and like, bring the support for those new frequency band onto the existing infrastructure?
Yeah, so this more of a product question, really. In my personal opinion is it is likely to be more of an overlay in the beginning with its own APs, its own core network and so forth. We'll talk about it in the later parts. But it will use the same Ethernet infrastructure, the same LAN infrastructure of the enterprise.
Okay.
So you won't need, new cabling and so forth for at least the solutions that we are building.
And we'll touch upon some of those Celona's thoughts on that maybe in one of the future sections. So it's a really good point that we will really touch upon.
Will the PAL licenses be allocated, sold, et cetera, based on like certain geographical swaths, or will a single entity potentially own that frequency range nationwide?
So the auctions are planned to be at the county level.
Okay,
So each county region will have an auction.
okay.
But, and then, as I said, the requirement is to have at least 2 entities bidding for it.
And there's a maximum per owner, right?
And the maximum spectrum that one owner can use, as I mentioned earlier, is like 40 megahertz.
Yeah, the nice part is even assuming full PAL done, you have 80 megahertz
still
of
a bunch of
GAA
spectrum left over.
always.
Exactly.
So that's the really innovative part of what FCC did with CBRS, is you have at least 80 everywhere.
And are these overlapping segments, or are they independent of each other? Will there need to be like a guard 10 megahertz on each side, or?
No, so that goes into some details of the RF, right? In terms of the proximity of these different entities and so forth. Typically not.
Okay.
So something you said is the max allocation per person or per entity is 40 megahertz. Does that mean that they only will allocate 40 megahertz like in this county and that's it?
For PAL, right? We're talking specifically for PAL. So the auction for getting the license as a tier 2 user per entity is limiting you in that county to 40. But you can, yeah, almost half, almost half of the 70. But if there is no other users for the remaining of the spectrum, right? If you got 40, there's this 110 megahertz. If there's under GAA, you can also operate on that. So this can be your PAL license, and the remaining can be your GAA operation.
So maybe going back to the question that was asked earlier, as far as how long can those services stay up without that internet connection? Those operators that are operating under a PAL license, they don't require that spectrum coordination, correct?
They do as well.
So they, even with that PAL license, they still, okay.
Because the protection is predominantly for the incumbent.
Exactly. So the tier 1, if you remember, the Navy radar or the fixed satellite users, they need some protection.
Okay. All right.
By the way, one of the other things about PALs, which is really innovative, is you can buy the license, but till you actually deploy in that locality, that is still available for GAA.
Exactly.
So you could have bought a 40 megahertz license if you have not deployed it. That 40 megahertz is still available for GAA.
And some people call this use it or share it.
Yeah, use it or share it model. Yeah.
So the transmit and receive frequency is always the same? Is this a half duplex?
This is an TDD system, very good point. It is a LTE TDD. Downlink and uplink are on the same channel, and there's different TDD configurations that are specified.
And what type of bandwidth can we expect with a typical 40 megahertz or 10 megahertz channel, depending on?
Yeah, so in 40 megahertz, as I was showing earlier, you can get up to 200 megabits per second downlink, and if you have uplink MIMO, you can, on the uplink, can go up to 50 megabits per second. It's peak rate, right? But then again, as a network, you have a lot of capacity.
Actual throughput, not necessarily advertised link speed, but.
This is application layer throughput you can get.
Okay.
So those of us with long memories, CBRS feels a lot like WiMAX did. Can you address what lessons we learned from WiMAX and why CBRS is not going to fail like WiMAX did?
A very good question, and I think this, I'll give you my personal experience. I mean, in that time period, I was one side. I was on the 3GPP2 and 3GPP side of that. What I have seen...
So it was your fault.
I think what I have seen is how the ecosystem built over time. And one really nice thing for CBRS with LTE is that there's a rich ecosystem of devices and enhancements that has been developed over the years. And there's a path evolving into 5G. So essentially, 5G NR is an evolution of the 4G LTE. And I think that path is very important for the evolution of the technology. And also maybe an interesting part to highlight here is the use cases and the business needs for the high-end, high-quality reliability that these applications require. And when you look at many of those applications, you see them in settings like enterprises, not not only in carpeted office type of enterprises, but many of the other use cases we'll later talk about in industrial use cases and so forth. With the high quality, with the evolution to 5G, I think is something that has a lot of momentum behind it. That I can say, I think, objectively.
I think you can't, I think we feel like we can't underestimate the fact that this is just standard LTE in this world. We are not bringing in a new thing. It's an LTE ecosystem, which has now existed for, 12 odd years, is the de facto for mobile, is the one that has embraced it, as opposed to creating a new ecosystem, which is a challenging thing.
But my shy little friend wants to know what happens if you dial 911 on this. Is there any location stuff that's weird or different or?
No, I think from a 911 perspective, it looks like another private network, to be honest with you. So it doesn't have anything unique relative to that.
Is that
you
like
can develop stuff on top of it, just like any other private network.
Is it a self-registration thing, you know, when you turn up the equipment and it goes to the FCC or something, does that automatically register?
Yeah. It's part of the requirement for the actual hardware of those access points or eNode Bs to be certified by FCC. They verify that they always do that.
So you'd have to enter in a physical street address, not just like a GPS.
One of the two. The how is not determined. FCC just cares that you give the location.
All right.
I think if I may add one more thing, you know, CBRS is not a new technology.
Oh, sorry.
This band is not a new thing to the world. It's just new to the United States civilians. So I think that the technology is already in place. The equipment in Asia and Europe has been manufactured and used successfully. So I wouldn't worry about whether, you know, it's something that would prove to be successful or not. With respect to 911 dialing that the gentleman asked, I think all cellular phone 911 is handled centrally somewhere on the East Coast. And you never reach the police anyway. You reach the sheriff's office through a central place. So I don't see how it would impact it in any way. It would be just like a regular network.
I see this in some parallels to like the FirstNet network that AT&T has built out for government use right now. Only this is more open to enterprise than everyone else.
Yeah, I would say it's like a new way of approaching spectrum, and maybe there are some similarities, but it's really enabling many use cases beyond the FirstNet does, right?
Yeah.
Do you see the FCC's approach to spectrum allocation here in CBRS? Do you see that being adopted in any other chunks of spectrum in the future? Look into your crystal ball, right? If you look 10 years down the road and this is a smashing success, right, are they going to do this elsewhere, like 2.4 gigahertz?
Okay, I'll pivot there, and instead of looking at my crystal ball for FCC, I will talk about what's happening in the rest of the world. And the rest of the world, many regulators are looking at the CBRS very closely. And now you're seeing in Germany, for example, Benitza, their regulator, has allocated 100 megahertz of spectrum from 3.7 to 3.8 for use of localized industrial or other type of enterprise use cases. In UK, there was an announcement, I think 2-3 weeks ago. They are taking somewhat similar approach of use it or lose it for the licensed spectrum. So in many places, we are seeing this model being observed and starting to be adapted. Now, in terms of what will happen in the millimeter wave and other parts of the spectrum, it's really hard to speculate right now. But this is like a groundbreaking approach to use of spectrum, and there's a big momentum. It wouldn't be surprising to see if this picks up really, maybe other parts of the spectrum, not every part, but maybe some parts can be utilized this way.
I do think there are two concepts in CBRS. One is the concept about how do you free up spectrum for cellular type of use for smaller and newer entities. That's kind of concept number one. That's the goal. And then the concept number two is how do you do it? And I think the how they have done using spectrum sharing and introducing this concept of SAS. I think concept number one is almost mainstream right now in the regulatory environments across the world. Everybody recognizes that they need spectrum, not just in the traditional way, but in some way to be offered for these types of use cases. I think that's very universal.
It's a good way.
The how they do it is, I think every regulatory body has a nuance, because quite honestly, the incumbent user of the spectrum is different in different countries. This was a very unique spectrum which was used predominantly by the DoD in a certain characteristic, and it fit really well for this sharing model. Others might fit into other models, like Germany, which has basically created 100 megahertz, which individual entities can just go and get that license. So I think both of those concepts are interesting. Sharing is being looked at, from my aspect at Federated, I could see that there was a lot of opinion to say, prove it that it works in CBRS, and there is a lot of potential in many other places. And I think that's, so future will seek its out.
When you see the FCC, though, taking steps like leveraging the internet as a transport mechanism for doing things like spectral control or spectral allocation, do you see any problems where the FCC at some point may step in and say, this has become a critical service for spectrum allocation, we're going to take over something on the internet to make sure that we maintain control so that people don't denial of service, a coordination thing, and then wipe out all CBRS in the States or something like that, right?
Yeah, I think it's an interesting concept. I don't think they're thinking of any of those from our perspective. We have not heard of anything to that effect at all. Mostly because
the crap out of me, right? I mean, you have a DDoS attack on the SAS service, and suddenly all your CBRS goes away in 4 hours or whatever the timing is, right?
Yeah.
Well, and I think that also goes back to Lee's point. What we're really saying with both that statement and the natural disaster statement is this is not something that we can we can't trust this in a disaster, right? Because those windows are so short. If we don't have that ability to call home, we lose this as a communication channel. And I think that's something that has to be considered as these things are implemented and planned. We can't look at this as a complete replacement for LTE. For example, I think about it from a public safety perspective because that's my role currently.
Sure.
So it's something that has to be at least.
I think that's fair. I think that's a great point. In fact, I think two things. I think that's a fair point, and I do think that there will be a little bit of self-selection of use cases for the protocol the way it's defined right now. And we'll hear a little bit more in the next section about that. But I do think also this is, in a lot of ways, from CBRS Alliance and FCC's perspective, a version 1.0. They're also working on the future, and I think all of feedback and discussions like this goes back. And I have hope that they could potentially come up with solutions for that as well, because they're not impossible to solve. It's just decide. Yes.
So there's another Wi-Fi vendor, I'm sure you guys are familiar, that's already shipping, CBRS access points, and they've been beating the drum since before they were bought 12 times in the last couple of years. But what is it? Were they just too early, and now we're suddenly reaching some kind of critical mass with regulatory stuff? And what's different today than what we've heard over the last few years and the last time we sat in another room like this, hearing from another gentleman, basically explaining the same stuff, although you guys are doing a great job. But, what has changed?
Yeah, fundamentally, this has been a journey. As Mehmet said, the process started in 2015. And what was required was that certification of these things called SAS to be able to use this commercially. And that had not yet happened when we started speaking about it, and is now happening in September.
So finally, the official initial commercial deployments are starting on this date, right? That's the key point.
If I may add to that, if it's any comfort to you, 2 years ago, CBRS Alliance had 6 members. Today they have
130 or so, I think.
130 in 2 years. So a lot of the largest organizations in the country are joining CBRS movement.
Is there no Is there no backup that the FCC has come up with of 4 hours and then maybe connectivity fails and they give you a 36-hour window to restore?
Just deploy a 4G backhaul to phone and turn on your CBRS.
Well, I was actually thinking of that.
Yeah.
I was thinking of, a donor antenna and.
Well, if this is going to be
that.
considered, mission critical or something, right, you would have to have some sort of redundancy built in for
There
that.
would be, it seems to me that there would be some way to have a redundant link.
Well,
Here's
here's the problem.
Services are going to be going out that WAN week anyway.
Well, so here's the other piece. Like,
Sure.
in the event, if we're talking this natural disaster thing, do you guys follow what happened in Colorado with all the floods? There was no cellular.
Right.
Right. So that's not an option. When their stuff goes down and lose connectivity, like cellular type technologies are done. That's why ham radio is still a thing in natural disaster.
Yeah.
I live in a hurricane
point.
zone on the Gulf Coast.
Yeah, that's satellites.
Agree.
Yeah.
Dial up.
A little storm called Katrina came through my neck of the woods. There was nothing.
Yeah.
Yeah.
Sounds good.